crimes with both direction and magnitude. Oh yeah! With both direction and magnitude. Oh yeah! Oh yeah!
Vectors in the plane. We are going to be discussing the basic introduction to what a vector is, how to calculate a vector from points in space, how to create a direction and a magnitude, or how to find the direction and magnitude of vectors. On the screen, you see a traditional vector. So what we see there is basically an initial point, a terminal point. You see it has a beginning and an end, and within vectors, that's a big deal. Vectors don't just they're not just lines. They actually have specific pieces. My initial point is exactly where it starts. Okay, my terminal point is the point that it's pointing in. It is the point that it finishes at. Vectors are written, they're basically arrows with length and a specific angle that they go in direction of. So when you're writing out your vectors, you have to be very careful. You can't just draw a line. It requires you draw an arrow. I think most of you have had experience with vectors. Most of you have probably done a lot of this in physics that you're taking this year. If you haven't, then you'll get to take that soon. So hopefully, I'm really hoping this is a big review for most of us. This will be a nice little kind of break from the new stuff or difficult stuff and do something that's a little bit simpler, at least to start with it is. So direction and magnitude. We determine the direction and magnitude of a vector much the same way we did last time when we did sine, cosine, and tangent. We're going to take 2 points. You have P1 and P2, that's my first point, Q1 and Q2, my second point. In order to find the vector that goes from P to Q, we subtract their coordinates. And it's important that I notice the way that the vector is written. Its initial point is P, the second point, which is my terminal point, is Q. And so we're going to say terminal minus initial. So that's why it's Q minus P for both our X and our Y, or our horizontal and our vertical components. So once I subtract them, it's going to give me two numbers. That's going to be V1 and V2, which are really my components of my vector, my horizontal and vertical parts of the vector that I'm going to be creating or drawing. Okay, magnitude. Now, if I've got the 2 points, magnitude is exactly the distance formula. We want to find how far is it from one point to the next. If you find the vector first, it's kind of taking that in 2 steps. So you see the distance formula, I've written it in 2 different forms. You see the one with the Q's and the P's, and you see the one with the V1 and V2. Well, the vector can be written like this or like this. Most of you are going to end up writing it with just two numbers. And so you're going to go straight here, and it's going to be pretty much like finding the Pythagorean theorem, which really, we'll see in just a minute what the components look like. If you look at the bottom, component form, it really is. If this is my vector that we had, if I draw in the components, I got the horizontal and vertical components here, that's creating a right triangle. So therefore, finding the distance of the hypotenuse would be just like the Pythagorean theorem. Otherwise, I'm finding the distance between 2 points. Here again, these are things that you've done over and over again, and you should find very easy to be able to find magnitude. One thing to note is something very special about a magnitude of 1. If you do the magnitude of a vector and it has a magnitude of 1, then we call that vector a unit vector. In any direction, it doesn't matter which direction it goes in. Now we have special vectors that go in the direction of the x-axis and the y-axis. We call those unit vectors I and j, and we'll talk about those a little bit later on. But any vector that has a magnitude of 1 can be a unit vector. Let's look at the component form for a little bit. I have a vector, the red vector, PQ. It starts at P, it finishes at Q, it starts at the point 0, 0, and the point 4, 3 is its terminal point. Okay. The horizontal component is the horizontal distance a vector has to travel over before it can travel directly up and finish at its terminal point. If I combine these 2 numbers, the horizontal distance, so this point 0, 0, this point would be 4, 0, that means it travels 4 units to go from its initial value here to the value right underneath where the terminal point lies. That's a distance of 4. I have to travel from 4, 0 all the way up to 4, 3, so that makes this distance of the blue vector 3 units. Therefore, I get to my vector 4, 3 by traveling 4 units to the right, 3 units up. If I were to have a negative component, that would mean either I'm traveling left or down. So I've given you, let's talk about finding components. So if I've given you PQ, you find 4 minus 0, 3 minus 0. So I get the vector 4, 3. Now, it doesn't always work out to be the same number, but I had 0, 0 as one of my points. Right? So basically we said it travels 4 units to the right and 3 units up. Find the magnitude just like before. I'm going to plug it in, work it out, and go here. Now, if you've already created the vector with component form, you're most likely going to go straight to the Pythagorean theorem part of it and just square them, add them up, and then take the square root. And it doesn't always work out nice. A lot of the times here, you really will stop and take a decimal and abbreviate that with some decimal place of 1 or 2 times or something like that. The instructions will be clear in the problem. Okay, moving on to a little bit more vector operations. Let's talk about adding and subtracting with vectors and a little bit of scalar multiplication. Scalar multiplication can translate into basically just the distributive property. So I've got 2 vectors, v, which is negative 2, 5, w, which is 3, 4. I want to do 3 things. I want to do, first of all, 2v. So basically I want to find a vector that's twice as long as v is. I want to have w minus v and 2v minus 3w. Okay, now I didn't put any addition problems on here, but if you can do the subtraction, then you can most definitely do addition. When we add or subtract vectors, it's basically like collecting like terms or adding and subtracting like terms together. If you look at section A, or part A, I have 2 times the vector v. Well, I literally just distribute the 2 to each part, and I get negative 4, 10. Self-explanatory. In the next part, it's w minus v. So I take w, I subtract v, and I literally say 3 minus negative 2 to be 3 plus 2. 4 minus 5 is negative 1. In the last part, I'm kind of combining my scalar product or my scalar multiplication with subtraction. So this one be a little careful because signs can get a little tricky. The first thing I suggest you do is go ahead and use the scalar multiplication and multiply through in each vector, and don't worry about the sign in between or outside the vector components. So I'm going to do 2 times negative 2 and 2 times 5 to give me negative 4 and 10. Here, it's minus, but I'm simply going to stay with 3. 3 times 3 to give me 9. 3 times 4 to give me 12. Notice I left my negative sign outside. I did not try to distribute. You know, you can, and you have to change it to a plus sign if you do that. To me, that's really not worth it. I'm just simply going to subtract now. Negative 4 minus 9, negative 13. 10 minus 12, negative 2. Okay? It can't get much easier than doing some basic vector operations with scalar and just addition and subtraction. Okay, the last thing I want to discuss as far as just the basics of vectors, well, let me call your attention one more time. Back up here on page 420 in your book, it has a couple of additional properties. There are a lot of just variations of what we've already talked about. I would like for you to go and look at that and maybe write in your notes, or even on the page here, giving you some space, to go ahead and add in the ones that you think are new that you didn't recognize or you didn't know what that meant, and go ahead and write those properties in either on this sheet or on your own notes. The last thing we're going to talk about is finding the direction of a vector. So basically, it's finding an angle. If we go back to the unit circle, we found angles by using an inverse tangent, and that's exactly what we're going to do now. Because each vector, if I really think about what I'm doing, I'm putting its initial point on the origin and finding its angle that it travels through. And so it's exactly like the unit circle. So tangent inverse of v2 over v1, or the vertical component, or the y component, divided by the x. In our unit circle, it was y divided by x. This is pretty much the same thing because our vectors is v1 and v2. So I do the inverse tan. and I've got my angle. So to find the direction of a vector, and now my vector here is v is 3i plus 3j. Here's a great example of our unit vectors coming into play and how we use those. Unit vectors, I've written them down over here, are 1, 0, and 0, 1. Okay, so if I were to actually plug that 1, 0, 0, 1 into my equation here and multiply through and add those vectors together, I'm going to get this one. Okay, 3, 3. And I wanted to find the angle that if I were to have drawn the vector 3, 3 on my page out from the origin, what angle would it be at? And so you look at it, tan inverse of 3 over 3 is just positive 45 degrees. Okay? That covers the basics of vectors. Now, we will discuss tomorrow, or in the next lesson, we're going to discuss applications of vectors. So we're going to take these concepts, these ideas, so you want to make sure that you've got all these parts down, how to find the magnitude, how to find the direction, how to combine vectors with addition and subtraction, scalar multiplication. So when we get into our word problems, which is probably the more difficult part of this, how can I set up my problem so that I can work out the algebra easily? Check this again. If you need to watch it again, take some notes, make sure you know how to find direction and magnitude most definitely. And then we will talk about this. Make sure you do the assignment on the board. Do as many as you can. If you feel like you've mastered a concept, move on to the next part. And then tomorrow we will discuss how to apply these vectors in context of word problems.